Hi, I'm Balaji Chippada and welcome back to my YouTube channel. In the previous Numpy series part 2 video, we have learned a lot of new things about Numpy, right? In this video, we will learn about how to sort a Numpy array, how to reshape, how to do manipulations on a dataset using Numpy, and one of the most important concept of Numpy, which is broadcasting. Broadcasting is a little bit complex to visualize, but I will try to explain it in detail so that it will not have any issues while understanding the concept. So without any delay, let's get started. So let's start by importing NumPy. I will just import this and then we will talk about sorting of NumPy arrays. So if you see, I am creating a NumPy array 2, 1, 5, 3 and 7. Now I want to sort this array so that my smaller number will be at my first position, and then I have 2 and then 3 and then 5 and then 7. So how do you sort this? So it is in ascending order, right? And usually you need to sort by doing a for loop, but you don't need to do all of those things. So numpy provides a function called sort, and you can use it by calling np.sort, and you pass the array that you have created and it will give you the sorted array. Let's execute this. So this is my numpy array 2 1 5 3 7. I have my sorted array 1 2 3 5 and 7. And if you remember the copies and views that we talked in the first video of NumPy, we have seen something called as shares memory, right? Now let's see if sorted array and the original array are sharing the memory or not. It is not going to share the memory. Okay, now in this scenario, what I'm doing is I'm calling this np.sort, and whatever the sorted all output that I got, I'm saving it inside a sorted array. What if I want to save inside my array itself? I can just say array equal to np.sort. So I can just say array equal to np dot sort, and then I can call arr. Like this I can do, but is there a better way of doing it? Yes. So that is where in place sorting comes into picture. When I say arr dot sort, by default the sorted values will be shifted into this array itself. So if I do this and if I print array, now my array is 1 2 3 5 1, which is my sorted, but initially my array is 2 1 5 3 7. So if I print array, it is going to be sorted one. If you see sorted array, which is the value of 1 2 3 5 7, and my array after sorting is also 1 2 3 5 7, and let's check if both of them are sharing memory or not. Even in this case, they are not going to share the memory because it is created before all of these things. Hopefully that is clear. Now let's talk about how you can do a sorting in descending order. So this is my array 1 2 3 and 5 7, and if I want to sort my array in descending order, it should be 7 5 3 and 2 and 1. So how can I achieve this? By reversing this array, right? So initially I will sort my array and then I will reverse my array, and I will get this. This is in the descending order. So I have my array 2 1 5 3 7, and I'm saying np.sort of array. So this will return you the sorted array, and after that I'm using this. I'm saying get me all the values in the reverse order of this array, and then I'm saving it inside my sorted array descending order. And if I execute this, I get the output as 7 5 3 2 1. Hopefully that is clear. Now let's understand how you can do sorting on a two-dimensional arrays, right? That is also important, right? Or else multi-dimensional array. Whenever we are talking about multi-dimensional arrays, the concept of axis comes into picture. If you remember our previous video, I have mentioned that when an axis is equal to 0, that means it's a column wise, and when axis is equal to 1, it's a row wise. Now let's understand this in detail. So I have my array 5 2 8 and then 1 6 7 and then 4 3 9, right? And this is my array. Now I want to sort my array either based on column wise or else row wise. So when I say axis is equal to 0, that means it's a column wise sort. So these three will get sorted. So it should be 1 4 and 5, and these three will get sorted, which is 2 3 and 6, and these three will get sorted, which is 7 8 and 9. So this should be my output for my column wise sort. Now let's execute this and see the output. If you see 1 2 7 4 3 8 5 6 9, same as the one that we expected. Now let's move on to the next one. I can do row wise sort as well, and if I execute this, I get the output in which it sorted row wise. So it should be 2 5 8 1 6 and 7, which is in the same order, and then 3 4 and 9. Hopefully you got the essence of sorting in multidimensional array using axes. Can we also do sorting with indexes or not? Yes. Now let's take this example. Okay, I have 2, 1, 5, 3 and 7. This is my array. And let's do the indexing as well. 0, 1, 2, 3 and 4. So technically if I want to get this sorted, I should get something like 1, 2, 3, 5 and 7, right? This is my sorting array. And let's get the indexes for these ones. So my index for element 1 is 1, so 1, and index for 2 is 0, 0, and index for 3 is 3, and index for 5 is 2, and index for 7 is 4. Okay, so these are my indexes from original array in which we want to sort, right? So I have my original array and these are the indexes of these elements to which I have to sort, and if I execute this array of indexes, I will get my sorted array, right? And how do you get these indexes? If you remember our previous class on argmax, something like that, which will return the indexes, here we will say something as arg sort. So if I execute this, so I have my array as 21537, and when I call np.org sort, it is going to return the indexes of each element that we should sort, and I'm saying array of sorted indexes, so I get the output as 1, 2, 3, 5 and 7. Let's understand one complex sort called Lexsort. Okay, here I have my numpy array 154143444. Now let's understand this. So here I have my array 1514344. Okay, now if I want to sort this, I should get something like 1 1 3 4 4 4 and 5, right? Now you might ask, we have two ones here, which position of one that it took, whether this one belongs to this one or this one, you don't know, right? Or whether this 4 belongs to this 4 or this 4 or this 4, because by looking at it, it might seem like okay, anyone is fine because all the values are 4. But if you look at the Python perspective, Python should definitely know at which index 4 should be considered first and at which index 4 should be considered later. So how can you do this thing? So that is where we have something called as Lexsort. So what we can say is sort this array based on the key of another array. So this is my another array B, which is 9404021. Okay, now this is my original array and this is my key array which I want to sort based upon. Now what it will do is initially it will check for values 1. So 1 is at position 0 and position 2, right? At position 0 in the key we have number 9 and position 2 we have number 0. So because number 0 is smaller than 9, the number 2 index from the original array will be the first one. Okay, and then 0th index, because it is 9, we will get the second element from here. Okay, and then let's talk about 3. We have only one 3 element, it will be added here, and then we have 3 4s. Now we need to find which 4 should come first. So in this position we have 4 as 4 and then 2 and 1, right? And in all of these things 1 is the smaller, so this final 4 will be added here, and then this 4 will be added here, and then the remaining 4 will be added here, and then based on 5. So based on another key, we are going to sort our original array. Hopefully that is clear. So here let's understand this. So I have my array A and array B, and I'm doing Lexsort of, you have to give the key first and then what array you want to sort. So I want to sort my array A based upon a key B. Now if I do sorted index, I get the indices, and if I execute this, I get all of my array A. Now let's talk about NumPy reshaping. Reshaping is an important concept and we use it day to day in the data science field. So I have my array which is 0, 1, 2, 3, 4 and 5, and because there is only one square bracket, it's a 1D array, right? Now I want to convert this array into a 2D array. So how can I do it? So for a 2D array, you need to have a two-dimensional space, right? M comma n, it should be anything. So let's say I want to convert this array into shape of 2 by 3. That means 2 rows and 3 columns, right? There are total 6 elements inside this, and I'm trying to convert into 2 by 3 matrix, which is of 6 elements in total. So the first three elements will get here 0, 1, 2, and the next three elements will be allocated here 3, 4, 5, and this will be a 2D matrix. So how can I do this reshaping? By calling a function called array.reshape, and I have to specify what shape I want to get. So here I'm saying reshape my array into a shape of 2 by 3. Now let's execute this and understand the output. See, I got the output. Now I have this 2D array. You can see, look at this number of squared or closed brackets. And if I want to convert this into a 1D array, I can just use a function called flatten. What flatten does is it will convert any multi-dimensional array into a 1D array. And if I execute this will become my array again 0, 1, 2, 3, 4, and 5. And I can achieve the same thing by using a function called ravel as well. And if I execute this, I will get the same output 0, 1, 2, 3, 4, and 5. Now this is my array, which is give me a minute. So this is my array and b.arrange of 6. And if I print array, so this is the one. Now what if I want to convert this into a two-dimensional array, but in every row I need to have only one element. I just need to add a new axis. Now let me explain this. This is my array. Okay, now this is 0, 1, 2, 3, 4, and 5. Now I want to convert this into something like this: 2, 3, 4, 5. So here I have one row and 1, 2, 3, 4, 5, 6, 6 columns. Okay, it's a shape of 6, but here I have 6 rows and 1 column. So how can I do this? I just need to add a new axis. That is what np.newAxis does. So if I execute this, I converted a row vector into a column vector by adding a new axis. That is what np.newAxis does. Hopefully that is clear. Now I can convert any array into a three-dimensional array as well, and I need to specify the shape by using the same reshape function. And if I do this, I get this. If you remember our three-dimensional array notation, so what I said, we have the blocks and then rows and then columns, right? So what I'm saying is convert my array into a three-dimensional array in which it should have 2 blocks, 3 rows, and 1 columns. And if you multiply all of this, you get 6 elements, right? Which is my array of shape 6. Now what is 2 blocks mean? So it should have 2 blocks like this inside your final array, and inside each of it you should have 3 rows and only 1 column. Okay, so I'm saying convert this into like this. So I have 3 dimensions. So I have 2 blocks and each of them has 3 rows and only 1 column. Hopefully that is clear. There might be scenarios in which you don't know the exact shape of calculation. So that is where if you know the number of rows that you want to do and you don't know the number of columns that you have to do, then you can just specify -1. And what Numpy will do is it will auto calculate. So if I print array here, okay, so this is my array, which is 0, 1, 2, 3, 4, and 5. Now you know you want to reshape this array of shape 2 rows, but you don't know how many columns you want to get. So in that scenario, you can just specify -1, and Numpy will automatically calculate based on the inputs that you have given. So here the total elements are 6, and when you reshape, the total elements are going to be same, and you mention that rows is equal to 2, and 2 into, let's say this is x equal to 6, so x is equal to 3. So Numpy will automatically decide that this should be 3, and it will do a reshape of 2 cross 3. Hopefully that is clear. Now let's execute this. So you see 2 cross 3, 2 rows and 3 columns. It's a 2D array. Even though you specified is -1, it will calculate automatically internally. Now you can do reshaping of multi-dimensional array as well. Now let's execute this. Now let's understand what is happening. So I have my array 1, 2, 3, and then 4, 5, 6. This is of 2 rows and 3 columns, right? 2 rows, 3 columns. Now I'm trying to reshape it into 3 rows and 2 columns. So how can I do it? So I will split. I should have 3 rows and 2 columns. So first 2 elements I will take 1, 2, and next 2 elements I will take in 3, 4, and next 2 elements I will take 5, 6, and I will keep it inside the square brackets, and this is of shape 3 cross 2. Right, that is what we are doing. We can even convert or reshape multi-dimensional arrays as well, given that the number of elements is going to be same. There should not be any mismatch. So what happens if I say something like this: 3 cross 1? Okay, and if I have to calculate total elements, it should be 3, right? Now if I execute this, this will throw an error because initially you have array of size 6 and you cannot reshape into 3 cross 1 because it is total of 3 elements, but you need 6 elements. Hopefully that is clear. Now let's print this matrix. So I have a matrix called 1, 2, 3, and 4, 5, 6. Let's understand the transpose of a matrix now. So this is my matrix 1, 2, 3, and 4, 5, 6. Okay. And this is of shape 2, 3 cross 2. 2 cross 3, sorry, 2 cross 3, 2 rows and 3 columns. Now what transpose does is it will transpose the axes. So the final output should be 3 cross 2. So internally what transpose does is it will transpose, or it will convert all of your columns into rows and rows into columns. So my first column is 1 comma 4, this will become the row, and second column is 2 5, this will become row, and third column is 3 6, this will become the row. So if you see this is of shape 3 cross 2, and we have just transformed the columns into rows and rows into columns. That is what transpose will do. Now let's understand how you can do this. So you can call a function called dot transpose and it will give you the same output, or else you can just do matrix dot t if you want to do it in place. Now let's understand one more important concept using numpys, which is dataset manipulations. So I have this sample dataset here, and let me explain the dataset a little bit. So I have id, I have name, I have age, I have score, and I have city. All of these are of my columns. You can talk like that. And all of the elements are separated by a comma. So these are comma separated values. And I have 1, 2, 3, 4, 5 columns, and there are around 200 rows. Okay, this is inside a text file, txt file. Now id column is the number of the row, like that, and name, we have the name, and we have the age, which is the age of that person, and we have something score. We can consider this as a marks, it could be anything, and from where he belongs to, he or she belongs to Los Angeles, New York, Chicago. So this is my data set. Now we will load this data set inside Numpy and we will do some manipulations on top of it. Okay, so here if there is a data mismatch, you can specify data types as well. So I'm saying id should be an integer i4, and name should be a string, and age should be an integer again, and score should be a float value, and city should be a string. If you don't remember these indexes or in this notation, please watch our previous video that where we have mentioned data types as well in the numpy part 1. Now I will specify this and how to load the text file into a numpy data set. So we have something called as np.generate from text, and you pass the file path that you have. And as I mentioned before, these are comma separated values. That's why I'm mentioning delimiter as comma, and I'm saying skip header equal to 1 because we don't want to read the values of the names. And then data type, I'm passing the data type that we defined here, and encoding UTF-8. If you don't remember about encoding, please watch our file handling video. Okay, now if I do like this, I get to load the data and I can print the data as well. Now it is inside a numpy array, and if I print this, so if you see, all of the records are loaded inside an array. Hopefully that is clear. Now I can access the values of each column by accessing the column names or header names. So I have my data, and as I mentioned before, I have a column called age, and if I say data of square bracket age, I can, and I'm saving it inside ages. Now I can access all the values of age inside these ages. And now I'm doing an indexing here. What I'm saying is get me the first 5 elements of the age. And if I show you this, so if you see, this is 20, 21, 48, 52 and 31. So I'm getting the first 5 elements of age by using these methods. Hopefully that is clear. And I can even do filtering as well. If you don't remember our previous video, we can do a lot of comparison operators as well using numpys. And let's say I want to get all the records in which age is less than 30, and I want to get the top 5 of them. So how can I do it? I will say data. So this is my filtering condition. I am saying get all records in which age less than 30. Okay, and I'm getting the records by applying this filter. So data of age less than 30, right? And I'm storing it inside young people, and then I'm saying young people of 5. That means get me the top 5. Hopefully that is clear. And if I execute this, I get the output. So Emily 20 and Robert 21, Smith 26, and Doe 20 are the top 5 records in which age is less than 30 after filtering. This is how you can do manipulations on a data sets using a NumPy. Okay, and what if someone asks what is the average score that these people got? You can just call the function np.mean and you can pass the column data of score, and I can execute this. I get average score as 74.21, and I can find all the unique cities that these people live in. I will just call a function called np.unique and I will pass the column data of city and I will get it. And I can even pass data of score as well in this scenario, and it will return all the unique scores that these people got. And if I execute this, I get all the unique scores. So like that, you by using NumPy functions, you can understand the data better. You don't need to look at the complete dataset line by line. You can just do some NumPy operations on top of it to get the statistics. Now, what if I want to get the first record of my dataset? I can just do data of 0 and I get my first record 1 Emily 20. So this is the same record, right? Now, what if I want to get some random records based upon an index? I can just pass a list of indexes inside my data using a square brackets and I will get access to all of those elements. See, I'm getting the first record and then the 12th record which is 11 Michael, and then 22nd record which is 21 Sarah, 29 61, all of these things. Now I can get the first 5 records by accessing using indexing as well. Now what if I want to get multiple columns at the same time? I can just say data of name and city. I want to get the names and cities and I want to get the first 5 elements. So I get first 5 elements like this. See, this is very easy, guys. Using NumPy you can do a lot of manipulations on dataset, but going forward in the next videos we will be understanding about pandas, which is much powerful than NumPy for understanding the data. Okay, now we have, let's say I want to get the first 5 elements of name and age, so I can get this. I'm just calling data of name and age and I'm getting the first 5 elements. So like this you can do mix and match a lot of operations, guys. I mean, everything is self-explanatory, but I'm just giving the code here. And let's say I want to do a multiple operations, like I want to get filter the data based upon the age and I want to get those people and the city which they live in. I can execute this. So these are all the people who are under age 30 and they are living in Los Angeles, New York, Houston, and their names are Emily, Robert, and Smith. So by doing a lot of NumPy operations, you can understand the data much better. Now you can do mathematical operations as well. Now what I'm saying is, for the first 5 elements of score, add plus 10. So if I execute this, so these elements will become 88.27. If you see this, so my first one is 78.27. I'm adding a 10, it becomes 88.27. And the second one is 59.16 and it is 69.16. And the next one is 57.24 and 67.24. Likewise, you can do a lot of operations on the same. And you can do a data reshaping as well. And you can do a lot of these things. And everything that we have learned so far on NumPy arrays, you can use it on the dataset and understand and explore the datasets, guys. Hopefully that is clear. If you have any queries so far in this sessions, please let me know in the comment section below. I will reply to each and every one of you. If you check my previous videos, I have replied to each and one of the comment. So if you have any queries, please don't feel shy and please comment it down in the comment section. Now let's understand an important concept called broadcasting. Okay, now let's understand this. So I have my array. This is my array. Okay, this is of shape what? 4 rows and 3 columns. So 4 rows and 3 columns. And this is another array which is of shape 4 rows and 3 columns. Okay, 4 rows and 3 columns. Now if I am doing addition of these two, what will happen is this element will get added by this element and this element will get added by this element and this will get added by this element, and we will do a element wise operation, right? And we get the output as this one. So 0, 1, 2, 10, 11, 12, 20, 21, 22, 30, 31, 32, which is of shape 4 cross 3. So which is of same shape as the both inputs, right? So this is a straightforward use case. Now what if we have something like this? So these are important. This is where the concept of broadcasting comes into picture. So I have my a NumPy array of shape 4 cross 3 and this is of shape 1 cross 3, right? Because I have only one row but 3 columns. This is of shape 4 cross 3. Now I want to add this 2. So what NumPy internally does is it will try to duplicate these records to match the shape of B. Let's say this is A and this is B. So for the array B, it will try to duplicate these records of the first row so that it will become shape 4 cross 3 and it is of 4 cross 3. Now it will add both of them element wise. Now I get the output as this. So if you duplicate 0 1 2 0 1 2 0 1 2 4 times, and this will become 4 cross 3, and now I can do element wise addition, right? So I get this output. So let's understand a third scenario in which I have this array which is of shape 4 cross 1, because 4 rows and 1 column, and this is a function 1 cross 3. I have 1 row and 3 columns. Let's say this is B and this is A. Now in this scenario, what will happen is it will replicate A 3 times, 2 times you can say, and it will replicate B 3 times. So now this will become 4 cross 3 and this will become 4 cross 3. Now both of them got same shape. This addition will be possible by doing element wise operation, and I get this output. So broadcasting, what it does is it will try to match the shapes so that this addition subtractions will be possible. Now what if I only give 0 and 1? Now it cannot be done with broadcasting, because no matter what I do, replicate the same one again and again, or replicate multiple times again and again, I cannot match the shape of this one. So at least one axis of element should be same. If you see here, I have 3 here and I have 3 here, this is matching. And if you see here, I have 1 here and I have 1 here, and this is matching. Like, at least this is not a complete rule, but this is what I look at least some axis should be matching to work for broadcasting. Now let's understand this in detail using the code. Now I'm creating an array called A by using a function called tile. If you see, I here 0 10 20 and 30, right? So let's execute this and let's understand that. So I'm saying 0 40 and 10. Okay, np.arrange. So what it will return, it will return me 0. I'm doing a step of 10, right, up until 40. So it will be 10 20 and 30. So this is my array in which it will return this, and I'm saying np.tile, and I'm giving a shape of 3 cross 1. So what I'm saying is it is rows and it is columns, and when I use a function called tile, it will replicate this. I wanted to have 3 rows, right? It will replicate it here 0 10 20 30 and 0 10 20 and 30, and because we have only one column, this will be inside my 2-dimensional array, and this is my only one column. Hopefully that is clear. And if I give it 2 here, this will replicate again 0 10 20 30 to have one more column, and it will create something like this. Hopefully that is clear. So here the shape is 3 cross 2, right? I have 3 rows and 2 columns. Now let's understand this. So here I got it as like this. So this is my A 0 10 20 30 0 10 20 30 by using a shape 3 cross 1. Now what if I will do 3 cross 2? I will get something like this. Hopefully you understand the essence. Now move back to 1, because I created this because it is the same as this one, right? 0 10 20 30. Now what I will do is I will do a transpose of A. As I mentioned before, transpose will change your columns to rows and rows to columns. Now this is my final A, which is my A transpose, and this is same as this one, right? 10 20 30 10 20 30 10 10 20 30. And now I'm creating one more array called B, and it is of 0 values 0 1 and 2, basically this one. And let's execute this. And if I execute this, now A is of shape 4 cross 3 and B is of shape 1 cross 3. Now if I do the sum, it will go inside this manipulation, second one, which is this, and I get the output as 0 1 2 10 11 12, 0 1 2 10 11 12 20 21 22, like this. So this is what broadcasting does. Now let's create A again, and I will convert this A into a column vector by using a np.new axis. If you remember, we have learned it before. Now my A will become something like this: 10 0 10 20 30. So this is what my third scenario is: 0 10 20 30. And now I will add this to B, which is of this one 0 1 and 2. Now I get the output as the dimensions of 4 cross 3. Why this happened? Because of the concept of broadcasting. It duplicated A, it duplicated B, and it added to get the result like this. Hopefully you understand the essence of broadcasting. Now you can try to do broadcasting of different shapes. If you see, as I mentioned before, I have my array A 1 2 3 and array B 1 2. It is of different shape. Now if I execute this, this will return an error. Operands could not broadcast together with shapes 3 of 2. So you need to have at least shape matching so that broadcasting will work. And that's all for this video, guys. Hopefully we have learned a lot of new things, like how to sort ascending order, descending order, how to reshape arrays, how to deal datasets using Numpy, and how to do broadcasting, what is the concept of broadcasting, and a lot of other concepts as well. So throughout the series 1 and 2 and 3 of Numpy, we have covered extensively on how you can use Numpy from scratch. And with this video we will be ending Numpy series. And if you want to learn more about Numpy, you can always refer to the Numpy original documentation page as well. That is much more clear and concise, and you have a lot of concepts to learn from as well. But whatever the concepts that I have covered in the previous 3 videos, those will be the concepts which are important and that we will use moving forward in the course of data science. Hopefully you learned something new from this video, and if you are liking what you are watching, please do subscribe and click that bell icon to get notified daily. And we will meet in the next video with a new video called Pandas, which is really interesting and which is really amazing, guys. So stay tuned for more videos.